Hello everyone, I am Prachi and today I am going to present on modern security tools and Hadoop integration, focusing on how these tools help make big data system more secure. In this presentation, we will start with a brief introduction to Hadoop and its security needs, followed by major security challenges, modern security tools, their integration in the Hadoop ecosystem, and finally the conclusion. So let's start. First, introduction to Hadoop and need for security. Hadoop is an open source big data framework for storing and processing large scale data. These are core components like HDFS, Hadoop Distributed File System for storage, then MapReduce for distributed data processing. As Hadoop cluster store huge business and user data, ensuring data privacy and protection is essential. Initially, Hadoop had weak or no built-in security, making it vulnerable or misused. It means Hadoop helps organizations store and process massive datasets, but as data grow in volume and importance, securing it's become equally critical. Earlier version of Hadoop didn't have a strong security feature, which led to development of modern security tools. Next, security challenges in Hadoop environments. So these are security challenges in Hadoop environment. First, unauthorized access. Multiple users can access shared data. Next, lack of encryption. Data can be exposed during transfer or storage. Next, weak authentication. No strong user verification in earlier version. Then data leakage and privacy issues. Sensitive information can be stolen, and then complex multi-node structure, hard to manage consistent security across all nodes. It means how clusters are often large and shared among users. This creates challenges like unauthorized access, lack of encryption, and privacy risk. Managing security across hundreds of distributed nodes also become complicated. Next, modern security tools for Hadoop. So these are multiple modern security tools for Hadoop. First, Apache Ranger. Apache Ranger provides fine-grained authorization and policy-based access control. Supports services like HDFS, Hive, HBase, and Kafka. Next, Apache Knox. Apache Knox acts as a gateway between user and Hadoop services and handles authentication and prevent direct access to cluster node. Then CarverOS authentication protocols. It is authentication protocol that use tickets for secure login. Then SSL or TLS encryption, and it protects data in transit between nodes. Then Apache Atlas handle metadata management and data governance. It means these tools work together to secure different parts of the Hadoop ecosystem. Ranger manages authentication, Knox act as secure gatekeeper, CarverOS handle authentication, and encryption ensure safe data transfer. And next, now let's move the most important part of this presentation, how secure access actually work in Hadoop. Whenever a user tries to access any Hadoop service, the request first goes through the Knox gateway. Knox gateway makes sure that no one can directly enter the Hadoop cluster. After that, the After that, the Carver OS authenticates the user by validating their identity using secure tickets. If the user is valid, the request moves forward. Next, Apache Ranger checks what permission the user has. For example, whether the user is allowed to read, write, or modify a particular data resources. If the permission doesn't match, access is denied immediately. And along with this, Hadoop also use SSL or TLS to encrypt the data while it travels over the networks. This ensures that even if someone interrupt the data, they cannot read it. Finally, the entire security system including users policy and logs is centrally managed by the administrator. It helps in tracking surprisingly activities and maintaining compliance. So overall, Hadoop security work through authentication, authorization, encryption, and centralized management, making modern data protection strongly reliable. Now let's understand how modern security tools integrate with Hadoop architecture using this diagram. As you can see in this diagram, the process starts from the user who want to access Hadoop service like HDFS or Hive. But before the user can directly connect the request, first goes through the Knox gateway. Knox acts as security gate. It ensures that only authorized user can reach the Hadoop cluster. Once the user request reach Knox, it is authenticated by Kyber OS, and Kyber OS is like a digital ID system. It checks if the user is genuine by verifying their identity through secure tokens. After authentication, the access to specific data or service is controlled by Apache Ranger. And Apache Ranger defines what action a user can perform. For example, some user might only have read access, and while other may have permission to modify data. And finally, the data transfer between the user and Hadoop service is encrypted using SSL or TLS. So that's even if someone try to encrypt the data, they cannot read. In short, this diagram shows a full security flow for user authentication to access control and secure communication, all managed through the Knox gateway in the Hadoop ecosystem. And finally, I would like to conclude the topic. In conclusion, Hadoop play a vital role in handling large-scale data processing across distributed systems. But without proper security, it remains vulnerable to threat and misuse. Modern security tools such as Apache Ranger, Knox, or Kyber OS, and Atlas together provide a strong layer of protection by ensuring authentication, authorization, and encryption and data governance. And their integration help organize, maintain data privacy, prevent unauthorized access, and build a secure big data environment. Hence, a secure Hadoop ecosystem not only enhances reliability and trust, but also ensure that critical information remains safe throughout the data processing life cycle. And thank you. It means Hadoop clusters are often large and shared among users. This creates challenges like unauthorized access, lack of encryption, and privacy risk. Managing